Hi class, so we are now ending our video series on spread footing design by discussing first the development length, and then next we check now if our design footing can withstand uh, bearing capacity, bearing due to due to it due to the concrete column, so hiwalay pa yung bearing na galing sa soil. Okay, so that is also an additional consideration. Okay, o nga pala, let's sa wall footing, we don't need to check uh, the bearing strength of concrete footing, due to the load from the wall, because uh, the wall, had its own code consideration, if we are going to connect it on the footing, at saka from the definition ng bearing itself, bearing stress itself from strength of materials, it is the stress due to two surface areas in contact with each other, and we don't know the entirety, the entire area of the whole footing, kaya hindi rin natin siya pwedeng uh, compute, and at the same time, uh, hindi rin possible yung ginagawa natin na 1 meter strip. Okay, so let's start this video. Okay. So let's talk about the development length, and we are to check all our design footings, if uh, the reinforcement had followed, the required development length. So first, what is development length? Development length is the length of embedded reinforcement, including pre-stressing strand required to develop the design strength of reinforcement to a critical section. So basically, our we designed ang purpose ng reinforcement natin sa footing, is uh, to help, somewhat help our concrete footing to withstand uh, tension, from the moment, so what do we usually do, if we found out that our reinforcement, yung reinforcement na meron tayo, is not uh, didn't meet the minimum required development length, so we usually do, hooks or bend, so let me show you, through problem number 1, how do we check the development length, okay, so here is our development length, so from section 425.4.2, so before we determine yung provided na development length natin from our reinforcement, let's check first what should be the minimum development length, so from section 425.4.2, okay, section 425.4.2, 425.4.2. This one, no? Development length, no, for the form bars and the form bars intention shall be greater of A and B. A length calculated in accordance with 425.4.2.2 and 0.2.3 using the applicable modification factors from 4.2.4, and letter B, 300 millimeter. Okay, so let's look at this table. No? So, okay, 425.4.2.3. No? So, this formula, 1 over 1.1 Fy over lambda F prime of C, psi sub E and psi sub S over C sub B plus KTR over dB. Okay, that is quantitative D sub B. And we have this table here. Now clears if we either use this formula or the other cases. No, if the clear spacing of bars and wires being developed or lap slice not less than D sub B, clear cover at least D sub B, and stirrups or ties throughout D sub B not less than the code minimum. No, so we have the following formula. No, so what are we going to use on problem number 1? No, so minimum development length, sabi, A, 300 millimeter. Okay? B, yung formula number, formula B natin. Okay? No, yung 1.1, like, okay? So, sana yun dito? It's written here. Okay, 1 over 1.1. It's just the same. No, they just presented different formula. Letter C, 6 over 10, then letter D, 9 over 10. No? So we determine the values first. No? So we have 300 millimeter, no? Pero we have to solve for B, C, and D first. No? Ang C and D, no? We are going to eliminate only one of it, no? By checking yung check natin if yung clear spacing at saka clear cover niya, no? So nakasulat dito ang clear spacing natin not less than D sub B and greater than D sub B. 2 D sub B. No? So pasok siya. Okay, clear cover of at least D sub B. So D is not applicable anymore. So we remove this formula. No? So this shall be not included in the calculations. Kasi pumasok siya sa condition na siniset na nandun sa table. Okay? So we can just compare formula B and formula C only. Okay? So ang C sub B, we should determine this value per C sub B plus KTR over D sub B. Okay? C sub B is the lesser of center of bar to nearest concrete surface. No? So, center of bar, we can say na ang nearest concrete surface niya yung nasa ilalim. So, 0.5 multiplied by 25, half of the diameter plus the concrete cover, 87.5. 1/2 center to center spacing of bars, 1/2 multiplied by 155. We just able to solve this, no? Okay? And 77.34. So we use 77.34 no, as C sub B. 48 T sub R over A transverse over Sn can be considered 0 for simplification. So C sub B plus KTR over D sub B should be less than or equal to 2.5. No? So we are able to get 3.09, no, which is greater than 2.5. So we just use 2.5 as our final value. no, for C sub B, KTR over DB. Okay. Next, what are the values of for lambda, for psi of t, psi sub e, and psi sub s? No? So here are the values from the table, no, on the code, written on the code. No? So lambda is 1.0 since normal weight concrete. Psi sub t is equal to 1 again, no? Less than 300 millimeter concrete. Psi sub E is equal to 1, no? No specified epoxy coating. Psi sub S is equal to 1.0 for 25 millimeter diameter and larger. No? So using substituting the formula, no? We don't need this one anymore, okay? We don't need this, no? So we don't need formula D, okay? We don't need formula D anymore. So we using formula B, the required development length 9 over 10, 275 over 1 times square root of 27.5 times 1 over 2.5 times 25, 471.96. L sub D is equal to 6 over 10, 275 is 1 over square root of 275 is 1 times 25 is equal to 786.61. And our provided development length, no? Yung ang sinasabing provided development length dito, yung length of bars na na ginamit na ginagamit natin to satisfy yung tension, no? So going back dun sa formula na ginamit natin for the moment, no? So ito yung magiging development natin kasi ang inanalyze natin siya as a beam, no? So this will be your development length. Yan. Half of kalahati ng, no? So yung value of x, we just reduce the concrete cover, no? So 1.2 minus 1,200 minus 75, no? So that is equal to 1,125 millimeter, no? It is greater than the required development length, so therefore we don't need any hooks or bends for problem number 1, no? Okay. So hindi na natin kailangang i-extend into hooks yung reinforcement natin. Okay? And since dalawang side naman siya, no? We have two sides of our, since it is a square footing, no? Development length for both sides are just the same. Okay. Let's check other factors, no, such as impending bearing failure due to the uh, transfer of load from column to the footing. No? So from section 422.8.3.2, no, considering the bearing strength, no, so located here, no, 422, section 422, this one, okay, no, so bearing strength of concrete members, no, so both are concrete, no, so consider the bearing force, no, so okay, no, so sigma b sub n, no, shall be greater than or equal to b sub u, no, so this yung b sub n natin at saka b sub u natin are both forces, no, in newton or in kilonewton, no. So B sub n shall be calculated in accordance with the table in 422.8.3.2, where A1 is the loaded area, no? So, and A2 is the area of the lower base of the largest frustum of a pyramid, cone, or tapered wedge contained wholly within the support and having its upper base equal to the loaded area. No? So, okay. And the sides of the pyramid, cone, or tapered wedge shall be sloped uh, one vertical to two horizontal. No? So, area 1 natin daw is the loaded area, meaning it's the area of your column, no? And area 2, no, lowest base of the largest frustum of a pyramid, no, cone, the tapered wedge contained wholly within the support, no? So, yung area na paglilipatan nung ah, load natin mula sa column. So, in this case, no, the area of our footing, no? So, looking at the table, no, so we supporting surface is wider on all sides than the loaded area. No, so we use the lesser of B sub n is the lesser of A or B. Square root of A2 over A1 times 0.85 F prime of C A1 or twice 2 times 0.85 F prime of C A1. No, so going back here, no? So B sub n natin, no? Column is at the center of the footing. So supporting surface is wider on all sides than the loaded area. So Bn natin is the least of A, square root of A2 over A1, 0.85 F prime of C A1 is equal to square root, no? So we apply this formula, and B, no? Twice ng 0.85 F prime of C A1, no? Kung 0.85 F prime of C A1 natin is equal to 0.85 times 27.5, 500 times 500, 5,843,750 newtons. So if we apply the factors to our computed force, no, B sub n natin is equal to 33 million for formula A, 11 million for formula B. So we use this value, yung nakabox na. Okay, yung actual nating B sub U, no, is the force acting on the column, no, which is also equal to 1.2 dead load plus 1.6 live load, which is 3,232 kilonewton. Okay? No, so BU shall be less than or equal to phi B sub n. Ang phi natin dito is 0.65, no? From this table, no? Bearing is 0.65, no? Okay? No, so phi, no? 3,232 is less than or equal to 0.65 times 11,685.5. No? So it is less, 3,232 is less than or 7,595.58. So we don't need any dowels for our footing. No? So ano yung dowels? No? So it's this one, yung meron tayong 90-degree na bali here, no? That will reinforce our footing, no, against bearing failure due to the column, no? Okay? So yung dowels, yung ini-extend na galing sa ini-extend na reinforcement galing sa column. Okay? No, so hindi lang 'yan yung kailangan nating pagtuunan ng pansin. We also need reinforcement for connection between column and foundation. No, so ang gagawin lang naman natin, yung reinforcement from our column, i-extend lang pababa sa footing. No, so from section 416.3.4 416.3.4, no? 416.3.4. Minimum reinforcement for connections between cast-in-place members and foundation, no? 0.005 AG, no? Where AG is the gross area of the supported member. Okay? So 0.005 AG times 600 times 600. No, not that. This one. No, 0.005, no, supported members the column, no, times 500 times 500 is equal to 1,250 millimeter. So ilang column reinforcement ang ibababa natin sa footing, no? At least 3 bar. Okay, no? So let's move on to our problem on rectangular footing. For problem number 2, we are going to check your development length. No? So same scenario pa rin tayo. No? Greater of A is equal to 300 millimeter. No? LD is equal to the same formula, 9/10 Fy lambda F square root of F prime of C, psi sub T, psi sub E, psi sub S over C sub B plus K sub TR over dB, no, multiplied by dB, or the diameter of bar. Formula C is equal to 6/10, no, Fy over lambda square root of F prime of C, no, psi sub T and psi sub E, multiplied by the diameter of bar. LD for formula D is equal to 9/10, no, Fy over lambda square root of F prime of C, psi sub T and psi sub E, no? So we know na we are only going to choose between formula C and formula D, no? And sabi dito, D is not applicable since yung clear spacing naman natin is greater than dB, the diameter of bar, and clear spacing is also greater than twice the diameter of bar. So clear cover is greater than the diameter of bar. So formula D will not be applicable, no? So okay. So we are just going to use again formula B and formula C. So let's solve for C sub B plus KTR over dB first. C sub B is, no, from the center of reinforcement to the nearest concrete cover, 0.5 times 25 plus 75, 87.5. 1/2 times 151.45 or 1, no? We have three different spacing, no? We have three different center to center spacing. 151.45, no? Ito yung na-solve natin, no? Short direction, long direction, and the center band, no? So short direction, and we have two formulas for long direction, no? Yung sa center band and yung the remaining part, no? So the smallest is 151.45, no? So we use 75.73 millimeter. Compute C sub B plus KTR over D sub B less than or equal to 2.5. 75.73 plus 0 over 25 less than 2.5, no? 3.03 plus 2 is greater than 2.5. So we use 2.5 as our value, no? Solving for formula B, 9/10 is 345 over 1 times square root of 28 over times 1 over 2.5 multiplied by 25. Our LD required is 586.79. And then formula C, 6/10, 345 over 1 times square root of 28 times 1 times 25, 977.98. So this is our minimum development length. and we compute the provided development length, no? So long direction 4,800 minus 2 times 75, concrete cover minus 600, no? So minus 600, bakit minus 600? So minus the column, okay, over 2. Kasi ang nung nag-compute tayo ng ah, nag-compute tayo na required reinforcement, yun lang ang kinonsider natin part, no, for tension. This is LD provided for long direction to 2025 greater than LD required. For short direction, 3,200 minus 2 times 75 minus 600 over 2, 1,225. Also greater than the LD required, so we don't need any hooks or bends for our rectangular footing. Okay? U is the 1.2 dead load plus 1.6 live load. Not force from the column, 4,176 kilonewton. B sub U shall be less than or equal to phi multiplied by B sub N. Okay, B sub N is the list of A, square root of A2 over A1, 0.85 F prime of C, A1. And B twice the 2 times 0.85 F prime of C, A1. No? Ang 0.85 F prime of C, A1 natin, no, is equal to 8,568,000 Newton. Okay, we apply the same formula here. No, in here we have 55,965 kilonewton for formula A and 17,136 kilonewton for formula B. No, so 4,176 shall be less than or equal to 60.65 of 17,136. And that is equal to 11,138.4. So no dowels required. Next, minimum reinforcement for connections between the column and the foundation. No, 0.005 of the area of the column. No, that is equal to 1,800 millimeter square. And if we divide it by the area of the reinforcement, now we have 3.67 or 4 pieces of bars. Now, 4 pieces of bar from the column, we shall extend up to the footing. Okay. Okay, so let's check naman the required development length, no, for our wall footing from sample problem number 3. No, it shall be greater than A 300 millimeter B for the same formula B. Formula C, no, the only difference is we have a change in formula for C and D because it's already 20 millimeter diameter or smaller, no? So we have here, instead of 6 over 10 and 9 over 10, we have 12 over 25 here and 18 over 25. No? So just read, no, yung what's written on the code, no? So we shall identify which of letter C and D are we going to use, no? So we know that our clear spacing is greater than the diameter of bar and also greater than twice the diameter of bar. Clear cover is greater than diameter of bar, which is equal to 12 millimeter, no? So your formula D is not applicable. So we delete this one, we remove this one from our computation, no? Okay. Huh? So let's solve for letter B first. No? So we have C sub B is equal to 0.5 times 12 plus 75 which is equal to 81. So lesser, yung pinakamababa from reinforcement to the nearest concrete surface. Next, 1/2 of the spacing, 165 over or 250. So maliit yung 165, so we use 165, 82.5. So this is the formula that we're going to use. Pero you know na C sub B is equal to 81 plus 0 over 12, 6.75, or which is greater than 2.5. So we use this formula. Okay. Next. Okay. Values for lambda, no, for psi sub t, psi sub e, and psi sub s are all equal to 1. No? Okay. So for formula B, 9 over 10 times 420 over 1 times square root of 21 multiplied by 1 over 2.5 multiplied by 12. That is equal to 395.93 millimeters. Formula C naman, L sub D is equal to 12 over 25, 420 over 1 square root of 21 multiplied by 12. That is equal to 427.91 naman. So LD provided, no, for the main bars, 800 minus 2 times concrete cover minus the length of wall over 2, no, is equal to 200 millimeter, no, and less than the required development length. So we're going to do hooks with this one. Okay, so how we do hooks here? Paano natin gagawing hooks yan? No? So, ito yung itsura ng reinforcement natin. No? So, this is your temperature bar, the one I marked in red. No? This is your main bar. No? And pag didesisyon na natin, no, we are going to decide if i-check natin if we're going to use 90-degree hook or 180-degree hook. Pero let's check first yung unbended leg na tinatawag. No? Yung unbended leg natin is equal to 800, no? The length of the footing minus the cover, minus 2 times 12, minus 2 times 6 diameter of bar. So, ano yung 6 diameter of bar na yan? No? The code, 6 diameter of bar, it's this one. No? So, pagka deform bar intention, no? Minimum inside bend diameter. So, ito yun. No? This one. No? 6 times dB, no? So ang distansya nito will be, no? So ang distansya nito, yan, from here papunta dito, no, is equal to 6 dB, no? Yung diameter ng malaking bilog na yun. Also same with 180-degree bend. Ganun din, no? So let's go back here, no? So 2 times 12, no, the whole diameter kasi isang buong bar, no? Isang buong bar nag-skip tayo, no? Ito yung concrete cover, minus concrete cover minus 1 whole diameter of bar minus yung 6D sub B, no? If we use 90-degree hook, 6 dB din pag 180 degree, no? So our unbended development length is equal to 482 millimeter. Pero tatanggalin natin yung concrete wall, minus 250 over 2, which is equal to 116 millimeter. Okay? No? So, what if, no, ginamit natin yung, if we determine kung ano yung gagamitin nating hook, kung 90-degree hook ba or the 180-degree hook. No? So what we do, no? So the length of hook is equal to the length of bend, no? Length ng bend plus length of the extension, no? So length of bend, no? Ang ginawa ko pala dito, no? Just sector of a circle, no? Yung r theta na tinatawag. R theta, no? So 6.5, no? Dahil 6.5 yan kasi 6 plus half of the diameter over 2, no? So multiplied by, kasi nga center of the bended bar, no? Multiplied by pi over 2, no? Indicates 90 degrees plus 2 plus 12 multiplied by 12. Yung 12 times 12 yan yung length of extension written from here, no? So L extension is equal to 12 B sub B for 90-degree hook. Okay, ang length of hook natin is equal to 205.26 millimeter. If we do naman 180-degree hook, no? So 6.5 times 12 over 2 times pi, no? Kasi 180 degree plus 65 kasi ang length of tension natin yung greater yung mas malaki between 65 millimeter and 4 times the diameter of bar. So plus 65 is equal to 187.52 millimeters. No, so we compare, we determine the development length provided. If we use 90-degree hook, 116 plus 205.26, we have 321.26, then 303.52. O nga pala, we compare it with the minimum required development length, no? So dahil may bend na siya, may hook na siya, no? Hindi na natin susundin yung kaninang code, no? So we have a new minimum development length required, no? For tension bars with hook, no? So development length from 425.4.3.1, development length LDH for deformed bars in tension terminating in a standard hook shall be the greater of A through C, no? So Fy over 4.17 lambda square root of F prime of C, psi sub E, psi sub C, and psi sub R. Now we have psi sub E, psi sub C, and psi sub R here, no, for the modification factors. Okay? No? So, no, not that. Ito. This one. Psi sub E, psi sub C, psi sub R. Okay. So, we letter B, 8 times the diameter of bar, and C, 150 millimeter. Okay? So, 0.24 Fy over lambda F prime of C, psi sub E, psi sub C, and psi sub R. No? So, we assume that itong tatlong psi na to is equal to 1. No? From the conditions given on the table. No? So, we have 263.96. 8 times diameter of bar, 8 times 12, 96. And C, 150 millimeter. No? So, pasok pa ang computed development length natin for computed development length, no, for the required development length, no? So pero what should we use? Of course, we use yung what should be the one, no? Ano yung mas economical sa kanilang dalawa, no? So mas maikli yung 180-degree hook, so we use 180-degree hook. Okay? So ang gagawin lang natin, no, yung main bars natin, babaliin natin into 180-degree hook like this one. No? So sa dulo. Okay? So Ayan. And similar with rectangular and square footings, no? Kung sakaling hindi nakapasok sila sa required na development length, no? We will just do the same here, no? Somewhat mahaba yung proseso, but uh, it's possible, no? Okay. Okay, I'm gonna end it here for now, no? Pero possible topics for the next video would be what should we do if uh, dowels will be required, no? And what if we have uh, footings that are eccentrically loaded, no, for spread footings din yon, no, kasi what we solved, no, on the previous videos, no, it's purely actually loaded foot columns, no, pero ngayon, no, magsasama tayo ng moment, no, or yung actual load natin, we are going to locate anywhere in the column, no, except on its center. Next, combined footings, no. So those are possible uh, topics, no. Pero for now, no, that would be all, no. So if you have any questions, again, don't hesitate to ask, and I'm going to uh, I'm going to leave, no, all my contact details, no, for now, no, and leave your comments below, and continue to like and subscribe to this channel and all of the videos that I uploaded here. Okay, thank you, and see you on the next video.